Good Friday to everybody. Good afternoon. Thank you for tuning in for today's session. Today I'm hoping to cover diagram as code tools and giving you a little bit of glimpse of some of the tools that I'm using. Not affiliated with any of these, just going to go through some examples of how and why essentially documenting and writing your diagrams as code is a good idea, and how you could be using it as part of your integrated flow of documentation and software integration as well. So without further ado, let's have a look at some examples of what I have for you today. I will be covering a description or a definition, if you like, of what diagram as code is. I'll be showing you some of the recent, most popular, the ones I know of, diagram as code tools. I'll be showing you some ideas about how you could be integrating diagram as a code with other tools, especially if you have an existing pipeline of different elements in your workflow that you are using, or if you are using already existing tools like CI, CD, so continuous integration, continuous development tools, such as GitLab or similar kinds of tools. But also, if you have a flow of your own, because it doesn't have to be that you are using an automated pipeline when you do software development, so your documentation steps, etc. I'll be demoing some of these tools. For example, Mermaid is a favorite one of mine, and I will be showing you some more and exploring some options in some of them that you might have already been using, like draw.io, but you might not really realize that it is possible to essentially maintain that diagram in code rather than drawing arrows and moving boxes around. And I will invite you, of course, to share any tools or best practices or ideas for diagram creation of your own. So essentially, it's not just me. This is what I'm presenting today is what I'm using, but that doesn't mean that these are the only tools available for people to use. So what is diagram as code? And why is it a good idea? So in software development, in machine learning, in design of pipelines, if you're doing cloud architectures, etc., we like to use diagrams. We enjoy visual documentation because we think this is crucial for our understanding of complex systems and communicating ideas effectively. So things such as diagrams, flowcharts, decision trees, UMLs, so boxes such as the one here in the middle that demonstrate, for example, a class, ERD, so entity relationship diagrams, which are essentially our ways of representing the relationships inside a database. They are all very, very helpful, and actually quite a lot of us when we learn, when we teach computer science, we try and get our students to learn how to draw these. They are the kinds of things that take loads of thought, but also because they are essentially a summary of your work at a glance, they take a lot of time to actually create. So stakeholders need them, they will ask for them, because they will not have to read loads and loads of pages of your documentation. They can at a glance understand the architecture, understand the design, and understand and of course discuss with you any issues they think there might occur when it comes to the behavior of the different systems and their parts. So it is a very important thing, and it's the kind of thing that we try not to ignore, and we try to get going really early on in our documentation process. So what is diagram as code? So it's a approach that's been around for a long time, but not many tools have been available for a lot of people to use. It's an approach of creating diagrams rather than using boxes and arrows that you manually put onto a canvas, onto a white space, and then save that as an image. It's essentially where you create that diagram structure and appearance and the relationships using code rather than through a graphical interface. And that can be really, really good, especially for developers, for people who aren't afraid of writing code. It can actually be a much quicker way of generating this. It allows us developers, software developers, systems developers to use text-based tools to generate these diagrams. And these days, um, version control can work nicely on them, but also because of the integration of the different tools and the ability now, for example, for markup to be displayed visually, for example, on GitHub, you can then integrate that really well into your development workflows. So key benefits that I have come across. First of all, you can version control them. You can just type in a slightly different code and you can change that diagram and make sure that you've got all the different versions in the same way that you would have done with a code file. Then automation, again, with the integration of those different systems and tools that can display markup or XML or different types of these in a visual format, you can get nowadays tools to generate automatically some of these diagrams for you as part of your CI/CD, continuous integration, continuous development and deployment pipeline. The other good thing about them is consistency, and you can ensure that all of your diagrams follow the same theme. Things appear in the same place, and of course, the really kind of irritating for some task of moving stuff around to make sure that it's all neat and it's got the same padding and the same space. It's very, very easy because all the kind of the visual and the kind of the interpreter, let's say, of that code program will do that for you. Reusability, diagrams can be reused with minimal effort, so you can copy and paste it. Let's say you had similar project with slightly different titles, you can just copy and paste that code in pretty much in the same way you would have done, and you can essentially just change the text and the whole diagram would change without the need for you to change a lot of things in it. You can also use variables in them. So you can essentially define a variable and then only change the text pretty much like you would have done with any of your variables in your normal code. You can actually also integrate it. So integration is another advantage. It is very good with other tools. It's very good with, they are very good, these tools, with integrating different platforms, and they are improving. And with the emergence of automation through generation of text and generation of code, this space is essentially getting more and more attention and traction. So watch this space, because there will be many more of these tools available for us to use and to essentially make that part of that documentation much easier, much quicker for all of us. How can you integrate that diagram as code? You can do that and essentially try different elements of that documentation process. So, for example, I'll show you examples of how you could integrate one of them using markup to write the syntax called mermaid.js. You can integrate it through a little tool on your Google Slides. So I will switch and show you in a minute how that can be done. You can do that through GitHub as well. So if you copy and paste my markup mermaid.js code onto one of your readmes, that the ones that end into .md, essentially, the actual chart of the actual graphic will be generated for you. So all you need to do is maintain your readme markup file, and then essentially that will do the trick for you. You can also use it in a sensible way, as you would have done any other text file, for example. So you can track changes, you can collaborate with team members, you can ensure that you maintain consistency, and so on and so forth. So let me show you just a second. apologies. Let me just check my share screen because that something seems to be off for just a second. Let me try and share that. Okay, so hopefully now we are looking at the right thing. Bear with me just a second, and I can now click on my live links here. So first all I want to show you is Mermaid. Mermaid is a JavaScript library that allows you to create diagrams and flowcharts using a simple text-based syntax, as I'm going to show you, a markdown-like syntax, really fairly easy to sort of follow through. It's designed to make it easy to visualize complex information, and it's got specific diagrams that it's very good at. Not all the diagrams that you might kind of think of. So let me just switch to if I click on that link to the visual edit of that and show you an example of what that might look like. So you can, of course, install that if you wanted to, and essentially have it. And I will show you how you can actually use it through Google Slides as well. But for now, let's explore the syntax. So they offer something called the Mermaid Live Editor. You could select from sample diagrams. So let's say I wanted to test out a flow. All you need to do is you start by declaring the kind of chart that you want created. TD means top down, so you can have it left to right. So LR would be what you would have changed it at. You see automatically my lovely diagram changes its direction from left to right. And then all you need to do is essentially define nodes. So A is my Christmas box, and B is my let me think box. C is essentially can be something that's my let me think decision matrix. And then from my C, then I've got D, which is my laptop, E, an iPhone, and then F here, a car. And you can see that I can actually use some font awesome icons in there if I wanted to. I realize these might be a little bit small for you at the moment to look at. So let me try and see if I can make this a little bit larger. Oops, that's too much. Let's try it that way. So hopefully the little syntax here on the left now becomes a bit more visible for your what you can look at. So let's say I wanted to change Christmas for summer. You see, it's on the fly, really. I want to change what goes on in the arrow as get money, which is essentially the description of what's going on is have fun. And again, see how straight away things change. B is decisions. And I will try to add another node. So let's say I want to define EDF G. So G is a new kind of box. That box will, it's complaining now because I am essentially not finished with what I'm trying to type. So G would be, let's say, a copy would go to, would be attached to A. So what if I do B goes to F, sorry, A goes to B and A goes to G. So I now have got essentially that. And let me define G because it will keep complaining. Let me call that essentially G goes to H. I'll just copy the car element here so that hopefully that will be okay and happy with what I've got to say. So you see on the fly things are moving and changing. My summer has now been, because I have an arrow like this, my has been a new arrow has been created directing me to G. I'm not giving it a name, so it's just taken G, and then G is then linked to an icon with some text in it, like the car, for example. What else could you do? You could do sequence. So you could be, again, this is very useful when we are trying to do things such as signals and messages in computing, where, for example, you have one part of your architecture sending a message and or transmission, and then there is a response back. So if you're working with APIs, for example, that might be very helpful. Here we have Alice and John. Alice will say something to John, and John will respond something back. So you see how easy it is that to first of all write the text on it, but also change and add loads and loads of different arrows there. What else can we get? We can get a class diagram. Oh my God, these are so difficult to put together when you're first learning how to do object-oriented programming or similar, and create your little classes and modules diagrams. They are so easy with this kind of notation. All you need to do is know what you want to put in it, and then define pretty much your class like you would have done in your standard object-oriented way. So you define a class with fish. So you see it shows up here. You did then have your integers. So this is all like your variables. An integer of size. So size int is the name of your integer of integer type. And then you essentially have your methods underneath. So can eat, other things that can happen. So the time it takes usually for us to create these when we first start it is super, super difficult. And there are so, now that we have this kind of syntax and we know that this is the way we can get something automated happening, essentially every time we update our Java or our Python, for example, methods, somehow these gets updated as well. So it's really, really good to have the capacity to do that. State diagrams, very easy. Entity relationship diagrams, these are very, very complex to do and draw, and with these notation it's super easy then to sort of go for arrows. This is using what we call in relationships in data relationship in databases prose notation. So you see these little things as one to many, many to one, etc. Relational database was the term I was looking for. Gantt charts, not so good, but possible, not too difficult. User journey as well could be used here for that kind of thing. Representing Git. So if you have got your own sequence of Git commits and branches, which you can get from your GitHub status, you can actually generate a lovely graph showing what's happening. Pies, mind maps, and more recently they've added something called packets. So for those of you who do networking, these are very, very interesting, and of course much easier to create compared to the effort that would have taken to create these boxes, align them and put them in nice boxes and split them, etc. So very, very handy from that point of view. Let me go back to my slides. So Mermaid is one of these examples, and here I've given you that example of the UML diagram in case something went horribly wrong with my live demo and I couldn't demonstrate. So another one of these tools that is sort of good at some other diagrams, so it's better in terms of the way to representing some of these diagrams, especially the sequence and the class and the object diagrams there, is a tool called Plant UML. So that's also free, so that's open source. And what you can do is you will need to research a little bit the different integration, because it isn't as simple as Mermaid. It doesn't work so seamlessly with some tools. So go and see what it tools it interfaces with, but it can allow you to create various diagram types, UML diagram, sequencing diagrams or sequence diagrams, flowcharts, etc. And they also have a live editor like Mermaid did, that you can use to experiment and see if this is for you. So Plant UML, and let me just show you the live demonstration of that, will look like this. If I type in, it's pretty much like the sequence diagram that you saw before. If I type in start UML and end UML, so it needs tags for beginning and end, this Bob, Alice, hello will essentially generate a diagram that looks like this. And of course, you can export this in various formats. You can see PNG, SVG, but also JavaScript as well if you want to store it as a JavaScript kind of output. Let's try and see what other diagrams we can get with this. So you can, of course, get sequence diagrams, and they look like that. So if you type in, if you paste that code to your live editor, but of course in your other ones, you will get something that looks like this here on the right hand side. You can of course use various of these built-in elements such as actor, so this will generate a special icon for it, boundaries, controls, entities, and database. So this is used quite often when we are trying to build these the sequence diagrams. And of course, you can make them even more elaborate and complex. So you could be changing the colors in it as well. And here, this code here will show you how you can do that. So, for example, you can get hex code in here, and you can make this. I have a really long name box with, in this case, green. Other things you could be doing, or other types of diagrams you could be creating here. Of course, documentation is very detailed here, so you can go and explore at your own time. User case diagrams. So these are the kind of diagrams that we sometimes build when we try to create user cases for websites, for example. Or software. You can get the usual stickman that everybody loves. You can of course get a proper user icon like this one, but of course other types and variations of the little stickman here. So you could be building slightly larger complex user case diagrams such as this one. So you start again with the start UML tag, you end it with the end UML tag, and you specify things such as left to right direction. So this is how your diagram will be built. And then you want an actor named guest as the main G. So you essentially define that G will be used later on inside. Or towards that, so that guest arrows leave from it, and you have a package professional defined. So this is this box here. Oops, sorry. And in it, we want an actor, so an actor icon with the caption chef, and we call that SC. An actor food critic, so here is the actor icon, and we call that food critic, and we essentially rename it as alias FC. The reason why we do them is because then we need these to draw the arrows, essentially. Then another package is created, so restaurant. We want use case, so this becomes essentially a kind of verb or an action. Eat food, and we give it an alias UC1. Pay for food, give it alias UC2. Drink, give it an alias UC3, and review UC4. And then all we have to do is take these aliases here. So in this case, it will be FC because chef as C. So C is not linking to anything. And FC will be connected to the review, and G will be connected to the other ones of these use cases. So very, very simple. You see, all I need to do to change that icon is to just change the letter from where and to where that goes. So very, very interesting things and really, really handy. As soon as you understand, you get a feel for what the markup language is doing, for you to get a better feel for what that does. Other tools that I have, I would suggest you try out. So draw.io is another one that you might have seen. Yeah, you might have used that as well for various elements and for maybe your own design as well. What you might not know is what you can do through draw.io is export your current diagram as XML. And actually, if you check when you save it onto your local machine, this is saved as an XML. So there are no icons, there are no images, there's nothing. All that this file stores is essentially the diagram as an XML. So if you open that XML, you can edit it, and you can essentially change the shapes and change the arrows there. I am running out of time, so I won't show you that. Perhaps that's something we can do at a future kind of session. Last one I want to show you is something called Python Diagrams as Code Library. Again, same kind of spirit, but the only difference here is if you like Python, if you work a lot with Python, these diagrams can be built from within Python. So you load some diagrams, like some libraries, like the diagrams library, and you can write the code here in Python on the left, and that would this generate is essentially the diagram on the right. So really, really handy. And again, no need for you to find out and copy and paste the different icons. And that can be done for loads of variety of icons, both for Google Cloud in this case and AWS. Worth noting that these libraries will mostly be about cloud infrastructure. So chances are that you might need to maybe reappropriate some of these icons, but it does have the basic icons that we need for building architectures and databases. But it doesn't really offer, for example, UMLs, or doesn't really offer sequencing diagrams, as far as I could tell. So, a good question. Why should I change my ways? I'm very perfectly happy. My suggestion would be that if you try to integrate this into your workflow, you will, of course, experience a steep learning curve, as we say. So that means that essentially in the beginning will all be all very new and all very difficult and all very awkward. But as you progress, you will then be able to take advantage of some of the latest technology in that space. So automating your diagram generation, getting some of these GPT-like tools to get some of these elements generated for you, embedding them in your documentation. So again, you could come up with a pipeline that doesn't really need you to draw and redraw and redraw. It can get that diagram updated for you. Also consider opportunities for automatic generation from machines. So for example, loads of SQL tools, Workbench is the one I've recently used, will generate a graph or an ERD diagram of your database at its current point. So you don't really need to do that yourself. Try and explore the tools that you're using already and see if they've got something available for you to generate these elements, essentially. Finally, it's also changing the way that we practice, and we are humans and we've got habits, but encouraging everybody to be part of the contribution of that diagram and reviewing the diagram as well as they are reviewing the code helps a lot. Have interesting discussions, helps a lot. Make sure everybody's aligned and on the same page when it comes to the architecture of these information pipelines, but will also help you at a glance at any point in time see where your architecture is or what your system looks like. So exploring integration with other tools is very, very useful, and it's something I would highly recommend. I'm just running out of time, so I would like to thank you here for joining in. Hope that was useful. If there are tools that you wanted me to explore with you further, please let me know in the comments. Also, if you do have something that I haven't mentioned here in this seminar and that you are using as well, please make sure that you mention them in the comments. And then essentially what we can do is we can make sure that we have further discussions about them. Hope that was helpful. Thanks again, and I hope to see you next week. Have a very good weekend.